And the idea is to break up a long message into smaller size packets. And each packet has a certain structure, which is determined by the protocol. So most internets that we use, certainly the internet, uses TCP/IP protocol, which says where the destination address is, where the sender address is, what all the different other fields are, where the content is. It gives the structure, the agreed upon language for how those packets are structured. So you have a packet, the computer, the browser will break up, or the server will break the packet up into pieces, and then send those packets, break the message up into pieces, and send the packets to the router. Each router then just has to deal with packets. So given an IP address, it has to figure out where is the next IP address to send it to. Which router do I send it to? I have a packet, I know it's supposed to go here, I know what my IP address is, which router do I send it to? If it's in the same area, if it's in the same local network, for instance at Brandeis we're 129.64.star.star, that's all Brandeis. Every Brandeis IP address has the form 129.64.something.something. So if a router, a Brandeis router, sees a message that has an IP address at Brandeis, it knows, it has the tables which tell it which router to go to. So the router here in this building will probably send it to the main router in Feldberg, which will then send it to the computer science router if we're sending a message to a COSI server. If it's going somewhere outside of the local domain, then you have a table, routing tables, which say where it should go. And the routing tables have are updated fairly regularly. In fact, when you register your domain name, you usually say how long the routing table should assume it's going to be stable. Like every 2 weeks, check to see if I changed my IP address. Or every hour, check to see if I've changed my IP address. So you specify how frequently the router should be checking to see if your IP address has changed. So the main idea is you take a packet and you send it, and it goes from router to router to router to router. So let me just help you visualize that with the tool called traceroute. So let's find, let's do a traceroute to the National Science Foundation. No, to the White House.
Traceroute.
What's that?
It's traceroute for Windows.
What is it called? Oh, TraceRT for Windows? TraceRT for Windows, traceroute for Macs. Here we go. 11 steps. So it went from 129.64.87.1, that's the router for the wireless here, to 10.254.3093, that's an internal Brandeis one. Here's another internal Brandeis server. 129.64.250.66, that's the outgoing router for Brandeis, one of the outgoing routers. From there, it jumps onto this knox.org and to Internet 2. So we are connected to a larger network called Internet 2, and it then pops off here at Transit Trail, and then goes on T-Bone at rr.com for the last few steps, which take you to the White House. The way this works is every packet has a time to live number in it, which gets decremented every time it goes to another router. So if you say the time to live is 10, and if it goes to the 11th router, it'll die. You can also specify that it should send the message back if it dies along the same route. So the way these things work is they first send a message with time to live 1 and see how long it takes to get there and back. And they do it 3 times and get 3 different numbers. And they do it with time to live 2 and see where it gets to and get 3 different numbers. And so on, all the way up to time to live 11. So that's how this traceroute program works, using the TCP/IP protocol. Yep, Sahar.
So looking at like say 10 and 11,
Yep.
is that like a normal user's home computer? Like, do packets go through my computer?
No, they don't go through your computer. They go through routers. There's special dedicated machines called routers. And in fact, the big, there are maybe a dozen or so companies that maintain the big routers. The ones that go across the Atlantic, the ones that go across the Pacific, the ones that go across the US, right? Which carry, millions of packets per second. And there's usually smaller networks usually get onto those big networks at what's called a point of presence. So they'll have a connection, special router that connects with these big routers. And that's, in this case, the big routers are Internet 2 and RR.com, I think, are the big routers. Let's go somewhere. Anybody know a URL of something in another country?
mbl.is.
What's that?
mbl.is.
mbl.is?
Yes. It's a news.
Okay. 13 steps. Ooh, 101 milliseconds. Man, took a 10. See, the other one took only 12 milliseconds. This one, and now,
It's slower.
and now we're getting into trouble. So what happens? Sometimes some routers refuse to cooperate, right? So they get this time to live thing that expires. They say we're not going to send a message back, and this thing has to wait for the timeout. So we're not going to get any more information from here because this 15th router is not cooperating. So we'll just kill it. But you can tell. Let's go to Europe.
We're just in Europe.
What's that?
ya.ru. ya.ru.
BBC.co.
That's it, you give you a domain name.
Oh, I see. I thought you were asking me a question. ya.ru. I didn't understand the question. Why are you? Am I what? Okay.
Who's the natural language source here?
You can set up your computer.
So you see
your
here,
router.
it jumped across the Atlantic.
Wow.
Here's where it goes across the Atlantic, and it
People
goes
route traffic.
on retn.net is the one that owns that Atlantic cable.
You just know that.
And here we're in Russia. No, you can just see the time. Look at the time. It's 12 milliseconds, then all of a sudden 150 milliseconds.
Wow.
Right? So it took almost 130 milliseconds to go across the Atlantic.
Yeah.
And this is near the speed of light. So let's look at. So anyway, you get the idea. It's fun actually to play with this and go to Japan and see if you
Go to one in Africa.
somewhere in Africa. Do you know Kenyan?
Yeah, nation.co.ke.
What is it?
Nation.co.ke.
Nation.ke.
Co.ke. Yeah.
Okay, let's go to Africa. Let's see when we jump the ocean. Did we jump the ocean?
Just
oh.
Died.
Just like
There
this.
you go.
No.
The
So,
very beginning, no?
well, look, yeah, right here.
7.8.
Right here, it looks like we're going across there from 7 cent. Oh, hey, it came back. And we got there.
It
Great.
found another, it's recursive for it.
It's pretty fast. Vario.net. Okay, so I wrote a little program that collected information on these trace routes from Brandeis to like a dozen different sources. And what happens is it's not deterministic. If it tries to send a message from one router to the other and it doesn't go because, say, that router is overburdened, it can try another router, right? But it'll keep trying, it'll back off. Try the same router if that's the only one, or try a different router. So you're not always going to get the same path for one packet to another destination. So I wrote a little program, here, Emacs, and collected a bunch of data and put it in this digraph form used by a program GraphViz, and it generated this.
Whoa.
So here, let me zoom in, show you what this looks like to make it a little more concrete. So here, starting at Brandeis, this is a few years ago, so this is not the way it is now. There's a lot more 10.0 stuff at Brandeis. But I was at one of these computers, and I connected, and it always sent me to the main router. And then, but from there, it sent me to a couple different possible machines. And the color coding is the first two IP address numbers determine the red and green color. Red, green, and blue, or something. I mean, the first three determine the red, green, and blue.
A, B, and C networks.
So that you can see roughly the same color means what network it's on, roughly. So you can see how these things typically flow through about 10 or 15 different routers, but usually only 2 or 3 or maybe 4 different networks. And sometimes, ones like this one's going to, I don't know where, apple.com, for some reason goes a long way. University of New Mexico. So so the idea then is you've got this network of computers connected by routers. So routers are the infrastructure that supports the messages being sent. Okay. If you're more interested in this, you can take Lubashira's Networks course and learn a lot more about networking. But I think I'm going to skip Secure Sockets layer a little bit. Maybe I'll come back to it later at some point. Then when you do HTTPS, you're establishing a secure connection using public key cryptography. How many people know what public key cryptography is? A few? That's just such a fascinating
I
subject.
wrote such a good guide to it.
But I don't, maybe tomorrow, if I have time tomorrow, I'll talk about it.
Do you want to try to connect to a certain machine? It's really funny if you try to do SSH to a certain machine. It's my work machine. Go do it. It's pretty funny. I set up some configurations, customized.
Okay, so if I SSH
129.64.8.139.
Yeah, this is yours.
Yeah, that's my work computer. It's gonna deny you. Yes, yes.
I want to, yes. Okay, so you send a message here, permission denied. And let's see, it had the RSA fingerprint. But I'll give you the lowdown. The short idea is that there's this technology called public key cryptosystems that allow you to encrypt information with a key and decrypt it with a different key. So usually the kind of cryptography we think of is the simple one is you've got a password that unlocks the information. But public key stuff, there's two different keys, one for encrypting, one for decrypting. If you know the one for encrypting, it doesn't help you at all figure out how to decrypt. Unless you know an efficient way of factoring numbers of 100 or 200 digits. If you know how to factor numbers of 100 or 200 digits, then you can break all the HTTPS stuff in the world. Nobody knows how to do this so far. So there's this very cool stuff, which I won't talk about now, but it allows you to generate a public and private key. You can do it really quickly and efficiently. Then you give the public key to the person on the other end. They give you their public key, and then you send information back and forth using the public key encryption. And since they're the only one with their private key, they're the only one that can decode it. And you're the only one with your private key, you're the only one that can decode it. Somebody can sit in the middle and hear both public keys coming by, and still not be able to intercept your messages at all. So it's really secure. Yep.
I'm still a little confused about what encryption is.
Encryption? Encryption is you take a piece of text and you convert it into some other piece of text or just bytes in a way that's difficult to go back. So you want to code it. Encryption is just coding. So you want to take something and convert it into an encrypted form where people can't figure out what the content is. And then there must be some way of decrypting it to get it back to the original form.
So how do you, are there different do you have to implement your own encryption style?
So what happens is whenever you do HTTPS, it automatically does an encryption. It has its own, it implements this public key cryptosystem.
Okay.
So it does it all behind the scenes. But basically what it's doing is it's sending a public key to the server, and the server sends a public key to you, and then you just send your messages encrypting with that public key. And you're the only one that can decrypt. The way that you get around that is if someone pretends to be the Bank of America, and you believe it, right? Then they send their public key, you send your public key, you communicate back and forth, and what they're doing, every time you send information, they're connecting to Bank of America pretending to be you, right? And then it's showing you the screen, so you feel just like you're connected there, but you're in the middle, so it defeats it. Yep.
So if you were to intercept some encrypted text, what would it look like?
Just bytes.
It's just a bunch of hacks.
Just a bunch of bytes, right? And you could in hacks it would be like FA, FC 9339, FC 5932579 that forever, right? So it's just incomprehensible. Okay, so let's go back. So we could go and talk a lot more about this. I mean, really, this is a whole course in security or cryptography. We used to offer a one semester course in cryptography. There's plenty to talk about there, but we won't do it. I need to talk about HTML and CSS in 30 minutes. But actually, luckily, most people have done some HTML. How many people have written a web page in HTML in the last year? How many people have written a web page in HTML ever? Okay, so most people have done a little bit, not everybody. So let me talk a little bit about it. So I think maybe I'll do it on the screen. Note start text. Okay, so HTML is a hypertext markup language, and let me talk about the grammar. So the grammar is you have tags, which are text surrounded by angle brackets, and every tag, almost every tag, has a close tag, which is the same text with a backslash. The code between the open tag and the closed tag is the element. So this is an HTML element, is the stuff between there. Elements are nested. You can't have them partially intersecting. Either one is inside the other. Yeah, one has to be inside the other. You can't have an overlap. So I couldn't do this. I can't have body and close body and then have head and, whoops, and then close head. This is not allowed. Because here's the body element here, and the head element here overlaps. Can't do that. One has to be inside the other. Is that clear?
Yes.
Right? Okay, great. So let me fix that. And in fact, every HTML page looks like this. It has the HTML tag, it has a head tag, which gives information that doesn't appear on the screen in the body itself. For instance, it has the title, which is on a web page, the title is this thing right here. Oops. This is, the title right here. 01 Basics, whatever, that's the title. So you can put title, my first web page, close title. There are, however, some tags that don't have a close tag. For instance, the break tag. So this is text, BR/. So if it doesn't have a close tag, then the convention, the XML convention, is you put a slash at the end. That indicates that it doesn't have a close tag. Horizontal rule is also one, draws a horizontal line across. Image is another one. So if you want to have a picture, you give it the IMG, sorry. IMG, you give it the source, which is the URL. /.
Don't you use the image href?
What's that?
href?
No.
And no, href is for a link,
Hyper.
and then slash. And also you should have alt text,
For screen readers.
Tim's picture, and you can say width and height, and there are a whole bunch of other things. So this shows another feature of HTML, which is the attributes. So a tag can have attributes, parameters, and the parameters consist. The parameters have two parts: the attribute name and the value. The value is always included in double quotes. So it's always some identifier equals double quote the value close double quote. I think you can use single quotes also, but it always has to be quoted. You can't have it unquoted or it's a syntax error. What happens if a browser gets a web page that has syntax errors in it?
Isn't it like 40 something? 404. Not 404.
401.
No,
Not 404.
it just says, oh, no problem, I'll just do whatever I
Just
think is
ignores
right.
it.
Oh, really?
So it doesn't generate any error, there's no error, you have no idea there's a bug on the page, it just tries to put it up, tries to make the best guess, which is actually great for writing in some ways because you make HTML and it always shows up on the screen. The problem is if it's not correct, different browsers will make different hypotheses about what you actually wanted and show different things on the screen. So it's good to validate your HTML, and there are validation tools. And I'll put one up. So here, so there are maybe 100 tags, 100 different tags, and each tag's got some number of attributes. Image's got a few. There's a couple other important ones. The anchor tag, which you give it an href, hypertext reference, and it makes a link, .edu, and then the element is underlined, or somehow there's some style that indicates it's a link. So between the open tag and the closed tag is the thing that you can click on. There are also formats for doing lists. So you have list elements, li, close li, those, and close ul. So this is an unnumbered list, ul. You can also do ol for an ordered list. Let's see, what are the other big things? Oh yes, you can jump into the middle. Oops, jump in the middle with a name equals, the anchor tag with name. This is like that. So if you do href, it's specifying to go out somewhere. If you do name, it's specifying a place you could jump to. So here I can say href equals $2. Go to the middle. And in fact, from outside, you can have a URL, something, this should have been notes.html. I could say notes.html $phi, and it'll jump to that middle place. And then, okay, so this is sort of a rough overview of HTML. There are lots of tags. There are tags for tables. There are tags for forms. Right. So if you're making an input form, you say what the action is. It's going to be say put. Let's see. The action is what server is going to be handling your data. HTTP colon my JBS 2011 server.com / cool.servlet, whatever. And then the method post, I forget the method names, post and get. Post and get, right. And then you have the forms themselves. So buttons or checkboxes or those kind of things. Text area, rows equal 5, columns equals 50, name equals bio, close text area.
With default text inside.
And submit, input, type equals submit. There's a submit button. Close.
Now is that JavaScript?
This is just HTML. This is the form.
But don't you need, for buttons and stuff, I thought that had to all be JavaScript.
No. For buttons, you can add JavaScript to a button that says on click. If you click on the button, do some JavaScript. So JavaScript is another programming language that has that runs an interpreter in the server in the browser. So the browser has a JavaScript interpreter, and when it gets the code for the web page, it's got the JavaScript code in there, and it runs the program, interprets the program. And you can have it, the hooks are, you can do it with an input or on a button. You can say, when the button is clicked, run this bit of JavaScript. Okay, so we can then view this, go here, file, open file, that would be on desktop, date modified, notes.html. There it is, Tim's picture. It actually wasn't the right, I didn't have the right URL for that picture, so it doesn't show up. It shows the list, shows the place I can type in. Submit query. Submit query sends it to myjbs2011server.com cool.servlet, but there was no such thing. Actually, let me do this to show you this little, if I say get instead of post, it's going to send the information.
Invert, can you invert?
What's that?
Invert colors?
Yes, I can. Server not found. Oh, that's too bad.
If you do your, like, the same notes.html, just,
How about if I send it to, that is weird. I'll send it to google.com. Maybe Google will try to handle my, just send it to google.com. Not a good idea. I'll try anyway. Reload, send. So it went to Google, and here's what it sent. It sent it as bio, that was the name of that text area, equals, and this was the text that I sent, that I typed in the form. Right? So it actually sends it as, if you say get, it sends the stuff you put in the form and as a query string at the end of your URL. And if you say post, it sends it a different way. In the HTML protocol, instead of saying, when you say get, you can also have some extra information that gets sent. We'll see, we'll talk about this more tomorrow with REST. Not tomorrow, in 2 days. Yes?
Is this a security feature to prevent phishing?
What's that?
Is this a security feature?
Having it go up there on the URL? No, it's actually, this is actually an insecurity feature. Because if you have your password and you do that, and you say question, it'll say question mark password equals haha, you'll never get this 99.99.
just search Google for anything.
What's that?
Just search Google for anything, and it'll have the same.
Well, yeah, actually, so search. Yes, I can do this. I can search for Taha.
And then
Texas
change.
Amateur Hockey Association. And if you do www.google.com, and do that again, and if I do Taha again, then you see up here, here's the query, Q equals Taha. Is what's saying what it's searching for. And also the language,
You type
language equals English. I could do another language,
Are you?
Hindi.
Oh,
So I
change
can get a
the
Google page, I think it's HI Hindi. Is this right? Does this look like Hindi?
That's really cool.
Yeah, that's
And then change the
Yeah.
Taha in the URL.
So instead of Taha, I could be looking up Obama.
Oh.
And so here's the Hindi page for Obama. Right? And it's all by the query string. Now, why do they do that? They do that because then if you bookmark this, you bookmark the URL, it's got the query in it. So you can go revisit that bookmark and get the search results back. Right? So anytime, this is a good idea to do anytime that you might want to revisit, have those parameters sent again to the server. Okay. So there are lots of ways of learning HTML. Here's a list. There's lots of tag lists. Here's a list of all the tags. This is W3 Schools. It's actually pretty good. So there's tons of tags. Some of these are outmoded, like code is defining computer code text. So that's actually, I guess you can do that. It's supposed to be specifying not the style, but the content. So HTML is supposed to be specifying content, yes?
Yeah, when you put in the program a link to Brandeis, right?
Yeah?
Can you test it just to?
Oh yeah, why that link didn't work?
Yeah.
Oh yeah, you wanted to see if that link works?
Yeah.
So it's, it was right there, yes? So if I go, where was it? Back. And I'll just go to another one. Your file, open file, notes.html, Brandeis, click on it, there we go. And in fact,
But the middle one won't work. You won't see it working, that is.
come on, let me go to ~Tim, and there's that picture, view image.
Copy image location.
So I'll just take this, copy it out, and paste it in. So here, where's my image? That was my image. And I'll just paste that image in. So now I should be able to see this image. And go back. Reload. Okay, so it's got the image. And you can specify the width and the height of it too. So I can say width equals 250, 250, height equals 100, no, 300, 400. There we go. Say, yeah, it didn't like that. Reload. It didn't cancel.
I find a lot of times when I update, you have to close the browser and reopen
Reload. Oh, no, you can do,
that's a
there we go.
caveat.
You can also do a shift reload. If you do shift reload, it makes a hard reload. Because what happens often when it goes out to get a web page, the browser keeps track of that web page and stores it in the cache.
Right.
And if you go and try to get it again, it'll say, oh, it's already in the cache, then I won't get it. But if you're actually writing web pages, you want to be updating that frequently.
Note this is actually the original sized image. It doesn't do any image formatting or nothing like that. So if you like post a big picture and just link it and resize it in HTML, you're still getting that megabytes of picture.
That's right. So it's if you want to have a little thumbnail picture, you have some gigantic, 20 megapixel picture, and then you're saying the width and the height are only 50. You're still sending 20 megabytes down. So it's better to actually remake little teeny pictures to get in. Okay, so let's go back to this. There's a wiki book, which actually looks pretty good. If you want to look up how to do forms, for instance. So here's some example about how to do forms. So I'm not going to, I'm going to assume if you want to learn some HTML, you're going to learn it on your own. I'm just giving you sort of the structure. But basically it is just that very simple grammar with the tags and close tags. And then everything that appears on the screen has got some sort of tag behind it. Okay, let's go back to CSS now, 15 minutes of CSS. So how many people have written a web page that used CSS in the last year? 1, 2, 3, 4, 5, 6 and a quarter. Okay, so the last couple years maybe. So HTML, you can think of HTML as specifying the structure of the document, there are heading tags, H1, H2, H3 for different levels of headings. There are paragraph tags, form tags. If you want to specify the way the presentation, the font color, the font size, the positioning on the screen, that should be done with CSS. Originally there was no CSS, it stands for Cascading Style Sheets. Originally there was none, and all the style was done in HTML. So you had a bold tag, an italic tag, you had ways of setting the background color as attributes, or the foreground color, the text color. But now you shouldn't, that's even part of the language now, but you shouldn't use it. Any style, any presentation information should be done with CSS. Let's take a look at a CSS reference here. So here's an example that shows the grammar of CSS. So for CSS, you have one way to do it is you can have the name of the tag. Can you see this?
Oh. There we go.
Okay. Now we can see it. You can have, here's the CSS specification. It says for all body tags, the background color feature should be this, where this is a hex number saying how much red, how much green, how much blue. FF is full, 00 is none. So this is some color, I don't know what it is.
You can also type just red. Or blue.
What's that?
You can also just type red, blue.
Yes, so there are different ways you can look at, there are different ways of specifying color. Here this says the H1 tag should have color, which means the text color, orange, and text align, how the text is aligned in the element is center. The nice thing about CSS is you have all these properties that apply to any tag. So background color you can apply to any tag, to a form tag, a button tag, a text field tag, text area tag, a checkbox tag, body tag, H1 tag. Likewise for the text color, for the font family, for the font size. So for any HTML element at all, you can specify any of these. They're completely orthogonal, which was not the way HTML originally was. Originally HTML, each tag had its own different attributes. Right? You had to look out for this tag, what are the possible attributes. With CSS, it's not that way at all. So here we can click on this, try it yourself. Right. So here there's a background color is this like blue color. I like FFCCAA, which I think is Adobe. Yep.
Wait, so you
Yep.
can use CSS at any time in your HTML?
So this shows HTML in the head, where you have a style tag with the attribute type equals text CSS in the head, and the CSS, and then that will say that the body has a certain style H1 to P. There are also ways of actually putting style directly in. You could say here, style equals background dash color colon black color colon red. And
So that's
but that's not that you really shouldn't do. It's not. I mean, it's easy and simple, but it messes up your code and it puts CSS mixed in with the HTML. It's much better to not do that. To put it. Let me get rid of that. Whoops. Let me get rid of that. To take the style out and put it up here. P. Oh, but there already is a P.
Put it in a class or
So what I can do is I can say, okay, I have a new one I'm going to call p.tem, which is this. Background color red, black, color red, close curly brace, make it look a little nicer, background dash color, like that. Okay? And then down here I say, how do I do this? Class equals 10. So I can abstract, there's an abstraction mechanism. We can say tag dot identifier that you make up, and then you can specify the paragraph with that identifier. Class
So
equals
you
10.
specify where you want the CSS to be.
And then I can put that on anything. I could put it on, I could have a list, li class equals 10, close li, close ul. And then here, but I want it for both p's and li's. I can say for anything. .tem should work on anything. Oops, cancel.
Professor,
Yes?
why is list always within a UL?
Because that's part of the structure. The li element means a list element, and it's either a ul or an ol. And a ul or an ol element can only contain li's. Can't contain anything else.
But isn't it redundant to have two elements at the same time?
No, because you might want to have something. No, ul says is a container for a bunch of list elements, right? And that's all it can contain. But you can have an ol, which is going to say a different style. And you can specify the style. In some sense, it is redundant. You could have just ul or ol, and then specify the list style in CSS. But that's a hangover from, or a hangover from earlier HTML. Yes.
Just so that I get it, when you p and then there's p.gym, what's the difference between adding the .gym without the p?
Okay, so P says for every paragraph we'll have this font size and font family. And what this says is everything that has a .tem will have this background color and this red. And if I said p.tem, that would say, well, only paragraphs that have the tem class will have this property. What if I did this? What if I said, okay, and they'll also have font size 50 pixels. So here I'm saying paragraphs should be 20 pixels, but .tems should be 50 pixels. And here's a paragraph .tem.
Shouldn't it be 50 pixels because one's more specific than the other?
Yeah, so what happens is they try to be whatever's more specific. The most specific thing takes rules. There's a whole bunch of rules about how the cascade determines the particular style. And I don't really know what'll happen. Let's see. Yes. I could also do this. I could then add yet another one. I could say, yes, but p.tim, that's going to have font size 6 pixels, 6 point. Ah, don't say it. I'm just getting confused here. So if I added that, p.tim, that's the most specific. You're specifying the tag and the class.
No, but the ultimate test is to move it above the P and see if it's like.
Okay, yes, so you can also say whether or not it has anything to do with the order in which it appears. So I could move this up to here and view it again. And it's still 50. Ooh, but this is 2.
Yeah, that's because you erased the p.tim.
Ah, I did. In fact, I erased the. Oh no, but it's a p.
So it doesn't shrink the p from 50
You have,
down to 20.
you have .tim, you don't have p.
Oh, what about the li? Because that's .tim. That's right. Okay, fine. Yes. Yep. Okay. You can also put the CSS outside in a separate file. The file would just contain this stuff here. And then there's a special tag for doing that, for specifying what the CSS file is.
Is there a difference between, are there like IDs and classes?
Yes, so an ID, if you can also give an ID to an element, which is a unique identifier. And you can use that ID, so let's do that. Let's have paragraph ID equals abstract. Konnichiwa. Okay? God. Wrong editor. So here, with an ID has to be unique. So if you have an ID for something, there can only be one tag that has that ID. Class, you can have classes, lots of classes have that class. But ID has to be unique. And then you specify it in here the number sign. So number sign, what do I call it? Abstract. Number sign abstract. And then you can have, the nice thing about this is you can do positioning. So you can actually say where that appears. You can say, I want it to be absolutely up here, always in the upper right corner. Or I want it to be center in the middle. Or I want it to be 50 pixels from the right and 100 pixels from the top. Yes?
What happens, so you just said IDs are unique, so what if you have 2 IDs specifying the same thing? Like if you do,
Two tags with the same ID?
Yeah, so if I do PID equals abstract, and then I have something else like,
like
a header,
Yep.
ID equals abstract.
It's a mistake, and your validator will complain.
Okay.
So the browser won't mind, and who knows what it'll do, right? Because it's not correct. Okay, so let me show you. Let me go back here, back. And to give you an idea of the power of this, there's this site called CSS Zen Garden, which is very cool. How many people know CSS Zen Garden? A few? Yes? So here, if you look at the page, here's the page source, the HTML. It has in here the style file. This says where to get the CSS. And it's 001/001.css. And there are a whole bunch of style files. And if you go down to, see where are the links? Here are a bunch of other links that are exactly the same as this page, but just have different CSS. They're exactly the same as this page, different CSS. And notice the use of the IDs, ID page header, ID quick summary, ID preamble. Div is a way of making a vertical division of space. It's just a container. And all these divs have IDs, unique IDs. So then, if you click on here, here's another one, same text, just different CSS. The same text,
Because it's
just different CSS.
You could
Exactly the same text, exactly the same content. Sakura. The only thing, see, it's the same list things, the same text, the same preambles and list fields, but the CSS changes. For us. So if you want the style of the page to look different, you do it in CSS, and it's extremely powerful. And if you use IDs, you can move them wherever you want. In fact, if we look here, I think you can look at the code.
Do you have Chrome on your computer?
What's that? I can do it this way. You can go here, and it's going to be here. Here's the code, 207/207.css. So let me just, oh, there it is. So in fact, I just get rid of that. There it is. So it gives the HTML, the CSS for the HTML, the body, and way down here are these. And notice these say, like, this linked list position is absolute. That means you're going to say exactly where it is. 150 pixels, 603 pixels from the top, and the left, 25 pixels from the left. Height is 550 pixels. Z-index is 5. When you have two things that overlap, it uses the Z-index to say which one goes on top. 1 is above 2, is above 3, is above 4. So it allows for overlapping to be disambiguated. And all these other ones here, let's see. So there's actually here, there's just a little bit. Here's position relative. So you get the margin and the width. And exactly the width and the height of these elements. And here you're saying, there's also padding and margin, which we talked about with the views. So they have the same box model. Every HTML element, you can specify the margin inside, padding outside, the width of the border, and vary it for the top, the bottom, the left, to the right. Okay. So, here.
Do you have Chrome installed on your computer?
I do have Chrome installed.
If you open that up and hit Ctrl-Shift-J,
Yeah.
you can view the DOM basically, and it's a very efficient
okay.
way to see what's what.
Okay, so we'll do this really quickly because see, I'm just about done. So I gave you a brief introduction to HTML and even briefer introduction to CSS. Hopefully, showing you that its power. And then there's a CSS wiki book if you want to go read more. CSS reference. I didn't at all talk about JavaScript. I'll try to talk a little bit about it tomorrow. I've got 1 minute, so let's try to do the Chrome thing. Chrome. And while that's going up, I'll go forward to CSS in Garden and get its address. So you can put the DOM. And here, type it in. And then what do?
Ctrl-Shift-J.
Control-Shift-J.
Command-Shift-J.
Or yeah.
Command-Shift-J.
Oh, Command-Shift-J.
Yes.
Downloads?
No, but that's down.
No.
So what's the shortcut for it in?
Is it a view? Is it a tool?
No. See.
Maybe it's Command Option J.
Command Option J. Yeah, that looks right.
Yeah.
It looks like it's trying to do something.
Is
that it?
Yeah, that's it.
Oh,
now,
good.
if you like hover over the tag, for example, the head tag.
Head tag.
Wow. It'll all go up.
Yeah, hover over. See.
Tells you where it is.
That's the entire like.
The
So if
whole
you.
document. Okay, let me go down here. Here's this div. Oh, I see.
Yeah, exactly.
Cool.
Now you can even open it.
Okay, there's that div there.
You can even open it and change its layout, like or erase this particular tag.
Oh yeah.
Just on the slide.
Cool. Yeah, so this is pretty powerful.
Wait, how did
Can
you
I shrink that in there?
How did you get it?
Command-Shift-J.
Ctrl-Shift-J on Windows, it was
Command
Command-Shift option. Command option J.
So yeah,
And
unfortunately I can't
it's got
see.
a JavaScript debugger as well.
Yeah, so pretty powerful. Okay,
Extremely
and this
useful.
shows all the styles,
You can actually change the way you can
the DOM, the breakpoints. Okay, yeah, so that's very nice. But we're not, this is not a course about this, however, I will want you to do some HTML for like web, like you can have help pages for your application with HTML and CSS beautifully formatted, really nice, and you don't have to do it with the Android app stuff. Oh, damn, we gotta go. So, because we have to go meet our speaker, and we need 3 volunteers. It didn't go before.
Oh, God, really?
It didn't go before.
What you do for free lunch?
Okay,
Free lunch.
Who's the speaker?
huh?
Who's the speaker?
It's Rob Lindemann on
Okay.
virtual reality.
Yeah, look that up. Yeah.
Okay, so who are these the 1st 3?
I'll give up going now for a guaranteed spot next week.
That's what I
know.
I'll do that too.
No, you can't do that. You gotta.
No, we can't
You have to sign
do that.
Can we just have the sign up sheet and
Yeah.
like
Yeah.
everybody gets
Okay,
a
from
chance?
now on, but for today, we'll just take 3. So who wants to go for today? Brandon Salon? Taha? Richard Abi? Sahar?
I love Brandon so much.
You won the last
These
one.
3 here.
I got it
Okay,
here,
let's go.
right on paper.
Can you make a sign up sheet for these people?
Will somebody stay in the room, then we'll leave?
Last time.
Nice.
I'll just need to get food, otherwise I'll be here. So who's going now?
Yes, thank you.
Wow, I'm really excited about that Chrome thing, that's really, really.
That drum thing, yeah.
I don't.
Better than
I used it last.
What it's gonna be really good for you.
Okay,
Who's going now?
we covered a lot.
Just like now.
Well, you can still see that website.
Just by getting that.
You can page somewhere.
Okay. Oh, you know what, also, covers for the Zooms.
Zoom covers.
Please pick up the Zoom covers.
Who's going?
Whatever possibly an extra micro USB is mine.
Okay, let's go. We gotta go back to the bus.
He wants to know
What's that?
the 3, 4 like.
What's the difference?
Taha, Jared, Sahar. Okay. Sure.
You got that bad.
I'll do when I get back.